An electron configuration of an atom shows how the electrons are distributed among the various atomic orbitals. The periodic table is arranged to show which subshells are filled as we progress across and down the periodic table. Oxygen has an atomic number of 8, meaning that the atom has 8 protons and 8 electrons. To write the ground state electron configuration, we start with the 1s orbital and continue to place electrons in orbitals of increasing energy until we reach 8 electrons. Recall that any one orbital can hold at most 2 electrons. Starting with the 1s orbital, which can hold 2 electrons, we write 1s2. Next, the 2s orbital can hold 2 electrons. We write 2s2. We have placed 4 electrons, meaning there are still 4 electrons to place. There are 3 2p orbitals, which can hold a total of 6 electrons. We place the remaining 4 electrons in the 2p orbitals and write 2p4. The ground state electron configuration for an oxygen atom is 1s2, 2s2, 2p4. Double check that you have placed 8 electrons. 2 plus 2 plus 4 equals 8. We use a box to represent each orbital. We place electrons based on the Pauli exclusion principle and Hund's rule. 2 electrons are placed in the 1s orbital with opposite spin. 2 electrons are placed in the 2s orbital with opposite spin. We place 1 electron in each of the 2p orbitals with the same spin. The 4th 2p electron is paired up in one of the 2p orbitals with opposite spin. This is the ground state orbital diagram for an oxygen atom. Calcium has an atomic number of 20, meaning that the atom has 20 protons and 20 electrons. To write the ground state electron configuration, we start with the 1s orbital, which can hold 2 electrons. We write 1s2. Next, the 2s orbital can hold 2 electrons. We write 2s2. The 3 2p orbitals can hold 6 electrons. We write 2p6. Thus far, we have placed 10 electrons. The 3s orbital can hold 2 electrons. We write 3s2. The 3 3p orbitals can hold 6 electrons. We write 3p6. The final 2 electrons are placed in the 4s orbital. We write 4s2. The ground state electron configuration of a calcium atom is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Double check that you have placed 20 electrons. We can simplify this electron configuration by using the noble gas core configuration of the noble gas element that most nearly precedes the element being considered. In this case, the noble gas would be argon. The argon core configuration accounts for 18 electrons. We add 4s2 to account for the final 2 electrons. We start with the shorthand representation for the electron configuration of calcium. We add a box to represent the 4s orbital. The last 2 electrons are placed in the 4s orbital with opposite spin. This is the ground state orbital diagram for a calcium atom. Remember that the notation argon in square brackets represents 18 electrons. Nickel has an atomic number of 28, meaning that the atom has 28 protons and 28 electrons. Let's start with the ground state electron configuration with the noble gas core preceding nickel. We start with the argon core, which accounts for 18 electrons. We have 10 electrons left to place. We move to the 4s orbital, which can hold 2 electrons. We write 4s2. There are 5 3d orbitals, which can hold 10 electrons. We have 8 electrons to place, so we write 3d8. The ground state electron configuration of a nickel atom is argon, 4s2, 3d8. Double check that you have placed 28 electrons. Remember, the argon core represents 18 electrons. We use a box to represent each orbital. We place 2 electrons in the 4s orbital with opposite spin. We place 1 electron in each of the 3d orbitals with the same spin. This accounts for 5 of the d electrons. The remaining 3 electrons are paired up in 3 of the d orbitals with opposite spin. This is the ground state orbital diagram of nickel.